Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay and having fun. Long time ago, one of my manager told me something which still resonates in my mind. He said, if somebody makes a mistake doing a work, whatever kind of work is that, do not make big deal out of that. However, when an employee does something good, make a big deal out of that. It makes sense to me. It's like giving motivation to a person who's not doing a good job. But if you do make a big deal out of it, that employee might get disheartened and, probably not perform well. But if you motivate that person, if you guide that person, and if you don't make a big deal of whatever they did wrong, that is a better approach. But anyways, having said that, my today's discussion is calculus lesson 52. What we're going to do is we're going to discuss L'Hopital rule. Okay, L'Hopital rule is really interesting. I find it very interesting and fascinating because it goes a little bit beyond imagination, and I'll explain you during my lecture how it goes beyond imagination. But basically, a French mathematician by name of, let's see if I can pronounce the name right, Jean Broglie, okay, came up with that in 17th century, and he named after somebody by name of Guillaume Francis de L'Hopital, okay. That's how they pronounce this in French, is L'Hopital rule. So let's go ahead and dive in and see what a L'Hopital rule is. Let me ask you this. If I give you something, say like, for example, if I give you something like 4x over x square, okay, this is a function of x, and I say limit of this goes to 0, okay, limit of x goes to 0. How would you solve that? Okay, so if I replace x by 0, I get 0 over 0, okay, which is basically nothing. It's 0, or you can say indefinite. No answer. There's no answer, right? So now this is no good. Even if I say limit x goes to infinity, okay, that is still going to be infinity over infinity, which is indefinite, no answer. So then this great French mathematician came up with a solution. He said, well, you're looking at it from wrong angle. What you should be looking at is from rate of change perspective, how an individual function behaves with time. So that's what we're going to look at. So let's say you have the same function, right? I'm going to say limit of x approaching 0, and you have 4x over x squared. All right. Now let me plot a graph which will make more sense to you. So let's say we have a y-axis and we have x-axis, right? So let me draw the function of 4 of x, all right? I'm plotting 4 of x. So if y is equal to 4 of x, all right? If y is 1, then this will become 4. If y is 2, this will become 8, and so forth. So when I draw the function of that, I get something like this, like a straight line, right? Going towards infinity. And when I draw the graph for x squared, I get something like this. Let me draw that in green so you guys can see. Okay. That's also shooting towards infinity, or if you want to look at the other way, going towards 0. What L'Hopital said was that don't worry about plugging in x is equal to 0 and then get 0 over 0 or infinity over infinity. He said, look at the rate of the change. How fast this function right here, which is x squared, approaching infinity, and then look at this function 4x and see how fast is that approaching towards 0. Okay, so both of these functions have basically a rate of change to approach infinity or the other way to approach 0. So that is what L'Hopital came up with, and we do that with finding the derivatives of the problem. Okay, and I'm going to show you a bunch of examples in my upcoming lessons to explain you L'Hopital rule extensively. Now, if you are planning to become scientist, one example I can think of is if NASA shoots up 2 rockets in the space and they have to go around the Earth indefinitely, all right? But they want one rocket to go faster and the other rocket to go slow around the Earth. That's where L'Hopital rule kicks in. You can calculate and come up with the functions which will say, okay, this particular function right here needs to reach infinity faster than this function. All right, so in this way, one rocket which is going around the surface of Earth will be faster, and the other rocket will be also going around the Earth, but it'll be at slower speed. So this is one of the application I can think of. I'm sure there are a bunch of other examples also, but that's all I can think of right now. But I just wanted to introduce you with L'Hopital rule, and I'm going to come back and explain you in detail by solving some problems. Thank you so much for watching. I really appreciate it. Till next time. Bye-bye.